and welcome. In this tutorial, we're going to create this voxel effect in Max. Okay, so the main idea of this video is to take an input texture, then we will downsample it and turn all of the downsampled pixels into cubes. So we kind of have 3D pixels, which are called voxels, and that's where the name of this video comes from. So this tutorial consists of 3 parts, I would say. In the first one, we will create this 3D grid of 3D voxels or cubes. In the second part, we will assign the pixel color to each of those cubes. And in the third part, we will use the brightness of each pixel to change the size of the cubes. Okay, I will start with a jit world as our rendering context. Here I have a P window so we can monitor what we're doing, and this is my input video. Okay, starting with the first part, which is creating the grid. In order to do this, I will first create a texture and then downsample the texture. And this texture will then be turned into a matrix. Okay, in order to do this, we'll have a texture. We can just say it's full HD for now, and we can say a depth 0. Then we can take a quick look at this. So this is my input video. Then I want to downsample this in order to be a bit more reasonable, depending on what kind of system you're running this on. Maybe full HD is possible performance-wise, but I will start with a lower resolution and then see how far we can go with this. I think I will now create a send object for the dimension. So let's call this one dim. And then, so the thing is, I want to preserve this aspect ratio, which we have here, which is 16:9. So changing the dimension should always take the aspect ratio into account. And to do this, we can use the expression. And then, so our first input will always be scaled by a list that's coming in our second input. And because the first input will just be an integer, we need the scalar mode 1. So then we can use a load mass to initialize our aspect ratio 16:9. So if I double click this here, so first we have 16:9, 32:18, 48:27, and so on. Maybe let's just also say load mass 5. So this is our starting point. Then we can create a receive object. Oh, of course, I forgot. We also have to prepend the message dim, because otherwise we're just sending a random list. Okay, now you can see we're downsampling this. Maybe we should also specify filter none, so we don't have any kind of interpolation going on. Okay. Then I want to turn this texture into a matrix. So we can use this jit.gl async read. Then I will create the matrix, 4 planes, float 32. I don't know, for now we can just say 16:9 and also say depth 0. But we also need to change the dimension here. Or maybe we can just say, we don't say adapt 0 and then it will adapt on its own. No, it won't do that. Okay. Then we can move on and create our grid. So I will use a jit.gen code box for this, and the rest of the, or pretty much the rest of the code will just be in here. So what do we need in order to create cubes? So we need a jit.gl grid shape, specify shape cube, then dimension I will use 9 by 9 because I think this is the minimum dimension you need in order to draw a cube, but I'm not sure. At least I know that this works. So color will just be white for now, and then we'll say automatic 0 so it doesn't render automatically. And so this is one cube, and in order to draw multiple cubes we can use jit.gl.multiple. Here I need to specify that I need 3 inputs, and the parameters for these inputs are the scale of the cube, the position, and the color. Then I can plug this in here. Then we can create dummy outlets here for now. So, or let's just say scale equals 0.01. Sorry, then the next variable is position, which is just 0 for now. And color is just 1, which is white for now. Then we can say output 1 is our scale, output 2 is our position, and output 3 is our color. Then we can connect those here. And now we can see that we have one lonely little cube that's right in the center. Because for now, all of them have the same scale, which is pretty small. We can also make it bigger. All of them have the same position, which is at 0, 0, and all of them have the same color, which is just plain white. Okay, then, okay, we have it downsampled. We have the system set up. Now we can create the grid. So in order to do this, I will use the signed normalized coordinates, which range from -1 to 1, because here we are in our 3D world. So 0 is in the center. Here we're moving x, y is in the minus direction, here in the positive direction, and the same for y. So positive direction, negative direction. So we need for x and y, I need coordinates that range from minus something to plus something. So in order to do this, we can say position equals signed normalized coordinates. And we also have to take the scale here into account. So now we can see that we have 16 by 9 squares or 16 by 9 cubes here. I will also create a jit.gl camera. So I can control how far away we are from our cubes. Okay. But now the scale is just like hard-coded in here, which I don't like because I want the scale to be or to change in relation to the dimensions or to the not to the aspect ratio necessarily, but to the dimensions that we have in here. So the more cubes we have, the smaller the cubes have to be in order to fit in the same space. That's essentially what I want to do. So in order to do this, I will create a variable called this one ratio. This one is a vector where for x I'm dividing the dimensions of x by the dimensions of y, and for y we have just 1 here. And then I can say scale will just be 1 divided by the dimension of the whole thing, which looks like this. But now you can see that we don't have squares. So in order to change this, we can then multiply this by our ratio. And then we also have to change the position and also multiply this by our ratio. And now we have the same aspect ratio as our input, and we have nice cubes. What I also want to do is create a parameter and call this one, oh no, sorry, that's not what I meant to do. Parameter, call this one size, and this will determine, yeah, the size of the cubes. So let's say this is 0.5. In order to take this into account, we can just multiply our scale by the size we just created. Oh no, sorry. And then we can access this from the outside, and you can see that the size is changing, but the grid stays the same. Okay, then maybe we could change the position a little so this covers the whole screen. So the position of our camera. So zooming in a bit. Yeah. Yeah, maybe let's use 2.5 here. Okay. Then we have the space, we have the aspect ratio. Also, if we change the cubes, you can see that they get smaller. Okay. Then I guess we can move on to assigning the color. So in order to do this, we could essentially just say color equals in1. But as you can see, first of all, it's the wrong color because of the texture to matrix conversion. So we need, first of all, we need to say .rgb. Now we have the right color, and you can see that this is upside down. So in order to change this, we can create UV coordinates where we just flip the the y component, sorry. So in order to do this, we can say UV equals the number of cells we have divided by, no, sorry, this is the current cell divided by the dimension of the whole thing. And then in order to flip the y component, we can create a new vector and say uv.x just stays uv.x, and then we say for y we need 1 minus uv.y. And then of course we have to sample this input 1 by our UVs. But as you can see, this seems to be shifted upwards by exactly 1 tile, because I think this is happening because of some rounding errors. But what we could do is we could create or get the size of 1 tile, which is exactly 1 divided by the dimension of the whole thing, and then factor or subtract this here. So we can say tile.y, so shifting the whole thing by 1 tile downwards, and now it's exactly where we want it. Okay. Then moving on to the third part, I'd say. So we have the position, we have the size, we have the color. Yeah, I can change this here. Okay, coming to the third part. So now I want to use the brightness of each of those pixels to change the scale in the Z direction of the cube. The brighter a pixel, the more of the cube sticks out. So in order to do this, we can, first I want to create a parameter, call this one AMT for amount. So this determines how much we want the pixels to stick out. So let's use something small in the beginning, 0.1. Then let's just call this one Z, because it will be the change in size for the Z component. So this is RGB to HSL. So we're turning the RGB value of our input into hue, saturation, and lightness. And then I want just the Z component, which is essentially the brightness. So we can copy this color, put it in here, and then just take the Z component. And then if we just look at this, you can see that it's now just a luminance. And we can now use this in order to change the size. So how will I go about this? I think I will reassign this. So the basic idea is for the scale to just say plus Z, so this being an offset. So in order for this to work, I need to create a vector where X is 0 and Y is 0, because we don't want to change those. And then for Z, we can take the Z we created here and multiply it by the amount parameter we created up here. And then, yeah, when we use this, you can see maybe let's just do it like that for now. So now you can see that their size changes. But I think, yeah, in order for this to look a bit better, let's create a material. Okay, this looks much better now. And what I also like to do, so when you look at it like that, you can see that the grid looks very regular, which can also, I mean, I don't know how it looks like on YouTube, but this can also lead to aliasing effects. So what I would like to do is create a noise offset so that each of those tiles or each of those cubes is just shifted by a very small random amount. In order to do this, we can, let's create a variable called this one offset. This will be, okay, just set it to int2 for now. Let's first create this. So what do I need? I need a jit noise. And I only want to shift it. No, I want to shift it in X direction and in Y direction. So we need 2 planes. Float 32. And then, yeah. Let's maybe just say this is 16 by 9 for now. And we can also change the dimension of this when we're changing the dimension of this here. So in order to implement this, first we need to change the dimension and then we need to bang the thing. So we can use a trigger bang list. Let's see if this works. Okay. Perfect. And so the numbers that are coming out of this one are between 0 and 1. So the displacement will be quite big, which I guess I don't want. So what I want to do is use the mix operator and say, okay, in negative direction and in positive direction, I want to stretch input 2 and then multiply it by a small factor like 0.1. So the noise offset will be in the range of minus 0.1 to 0.1. Then where to apply this? I think we can just add this in here. Offset. Let's see if this worked. Did I get an error? Because I don't see much of a difference at the moment. Okay, now. Okay, maybe this can be a bit more exaggerated. Something like this. And I think what would also look cool is if we tilted this a bit. So something like that. Yeah, so I guess you can play around with this, try to use different input textures, change the size of these, change this a bit. And then, yeah, depending on how powerful your system is, you can also try to change the dimension we're using here. Okay, with 640 and 360, my computer seems to be slowing down. So, but now seems to be fine. Okay, I think that's essentially it for this video. I hope you found this useful. Thanks for watching.